All right, I learned a thing, and I wanted to. I got done my work early, so my after work, and I'm still thinking about how I want to get these new style rules to actually work. And the mechanism I come across that I hadn't poked around before was the proxy object in JavaScript. I wonder when it came into be. Um, Usually MDN's pretty good at telling us when it arrived. Look at that. Initially defined. So it's been there a while. This is quite cool. Let's check its compatibility. I mean, I'm expecting Node will do it just fine, but I'm curious. Huh, look at that. Internet Explorer doesn't do any of it. I'm shocked. Looks like everything else is pretty broad coverage. For the things that I want to know set, I want to know has, I want to know get, I want to know define property, delete property. These are hooks I'd really like to know about. Because what I was starting to fall down was, do I need to, let's see, where was I? Do I need to provide, oops, I'm on the wrong branch. Let me switch over. Do I need to have these wrapper functions at all? Maybe I don't. Wouldn't this be cool? So I thought I'd pop onto the stream again and just try some of this stuff out. Not sure if you've tried it before. Doesn't matter, I'm here to have fun for me. And maybe you'll get something out of it. I'm gonna switch over here and let's see. I'm just gonna pop up. Oops. How about I type in the window? There's a good idea. So in Node, I'm gonna make this a little bigger because I want to think about it in kind of big chunky playground mode. All right, so that has me on Node. So I need an object. So let's say I'll build myself a target. Target is an object. It's got no properties, which could be fun. Now, the way proxy works is you give it a target and you give it a handler. And the handler contains the methods you'd like to intercept. So why don't I make a handler with set. So set receives the object, the property, and the value that, and here's what I'm not sure, that is about to get set or was already set. That seems like an important distinction. I'm not sure if I need that level of granularity though. So let's pretend. Let handler be a thing where we got a set method that takes object property value and does something with it. Ooh, maybe I am expected to use the reflect. To actually set the property. This could be very telling about how this stuff works. I'm not a big reader of documentation. I like to play. So what if I just say for now, let's log out our object, our property, and our value that we got as part of that. That's going to be our handler. So how do we... Oh yeah, so okay, so we got a proxy right out of that. So let proxy be a new proxy for our target with our handler, right? So P looks like that. So P dot blah just did that. Ha! There was the object. There was the property. There was the value. Now, what's in the proxy? Nothing, because I didn't set it. What's in the target? Nothing, because I didn't set it. So, if, say, I log it, and then after I log it, I reflect, set, and what was that sprint operator they were using? Arguments. So let's do that, yeah? Ooh, already being declared. Oh, it was a let. Pop myself out of that, pop myself in a new node instance. Let's do this again. Let's start with a target. Oops. Let's start with a handler. Ooh, not that handler. This handler. And our proxy. Right, so now I do that. I get my arguments. The property is set in the proxy. The property is set in the target. Ooh, this is way too much fun. Now, I have a situation where I might have a whole series of nested properties. Now, I may not want to have to populate proxies through the whole object graph. I wonder how that works. What if P blah is a new object with a message in it? So that all makes sense. A proxy object has that embedded object, as does our target object. Now the question I have is, how deep does the proxy go? So if I say the proxy blah message equals goodbye, what do I get? No interception. The proxy is not on the object. The proxy's property has been set, but it's only watching the immediate properties of the object. So if I set anything inside it that is yet another object, then I'm going to need to wrap it with a proxy so that I can do recursive interception. And I think this mechanism is going to work for what I was hoping to accomplish. If I just don't do this, if I'm using a proxy here, now the very first thing that my engine is going to have to do, and let's plug this in. So let's see, my engine sets up, and it gets executed with a working memory. Now, I thought the first thing I did was clone the working memory. that I suppose I only clone the working memory on the way into the consequence. Something interesting too is because these lambdas are just lambdas, they're going to let someone use any code they want in the condition, including code that might mutate the working memory. I don't want that to happen. So if I have a handler that is a read-only handler, then the working memory that the condition receives can simply be a proxy with the read-only handler, and no changes will be allowed to go through. The consequence would have a read-write handler, and the read-write handler would record those things. So I'm going to end up with a change in some object deep inside the graph. I could start with a one-level implementation of this, and then I can noodle around on how to make this recursive across a whole graph of objects in working memory. And I think this is a worthwhile exercise. This could be remarkably cool. So let's see. I have proxy. Let's see if I can do the read-only proxy on working memory for the first set of properties. I'm not doing nested objects, just flat old properties. Currently my tests only execute on that flat set of properties. So here's what, let me clear this playground out, because I don't need that anymore. I think that I can do this better. So let's see, what would a read-only proxy look like? Clearly I would have to stub out and probably throw an exception across the methods of the handler that would mutate the data. So that would be delete property, define property, set. I wonder if I stuck with those simple things for now. Define property, delete property, and set. So what would that handler look like? Let me prototype it in here and then see where we go. So should be able to do it read only. Actually, what if oh, I don't even know where this wants to go yet. No properties. I didn't know what I'm writing here. But I just want to get to the point where, what is it? It is handler. So let our read-only handler be something that overrides set call this condition proxy handler. These messages are always going to be the same how does JavaScript work again? In my code. Why am I even looking out there? Yeah, I think that that's right. So the set property of this object is a lambda that throws. Well, you know what? That thing, that lambda, that no mutate handler. That looks still broken. Boy, it really likes that to be in a block. All right, that is fine by me. So the set is going to use the no mutate handler, and the define property is going to use the no mutate handler, and the delete property is going to use the no mutate handler. Actually, let's call this something else. Let's call this a no mutate lambda. Set define delete. I think that's good for now. So that's interesting. If I do this out in my REPL here, then I build myself a new proxy on the target. With that handler. P2 is a thing. And I can't do things with it. Oh, this makes me happy. All right. So I can make the thing read only. Well, let's try that. Set myself up a proxy, and then I can attempt to do the thing. So yeah, that's right. So I ought to be able to expect that this lambda that's probably good enough. Does this test pass? Yeah. So now that I about know how to do that, what I really need to do is I need the engine, when it calls the condition with working memory, I wanted to send in a proxy with that no mutation handler on it. Now, what if I set this stuff up in the constructor? So these things, we'll make that condition proxy handler a property of the Maxim Engine object. And when we call the condition, we're going to do so with the new proxy that contains working memory and the condition proxy handler. Well, let's prefix that, shall we? Now, that's about how it'll work. Okay, so I'm writing too much production code here. What I need is a failing test. So let's see. Let's make a test. Should not be able to mutate working memory in a condition. Let's do that. Don't need to do these anymore. It's going to be part of the object. I'm still going to have an initial object to work with, and let's see, I'm going to say let's register a rule that attempts to mutate in the condition. Right? That ought to completely fail us. And do I actually need a consequence? Probably don't. It's an interesting thing to write. And then here, I ought to be able to expect that when the engine executes on the target, it's going to throw that error. Now this will fail, or it should fail, because no error is being thrown. What? No. Okay, something's busted. What's busted? It's like I needed a consequence. So, okay, I got the throw that I expected. And of course it didn't throw. So if I wrap this in that proxy, you unhappy? Not enough brackets. I like this. This is excellent. I should probably check the other kinds of mutations that I have handlers for. Which means I probably should have started with one handler at a time, like thus. Alright, so I'm going to comment those out because I wrote too much code. So I'm going to backtrack a little bit, introduce the failing test, put in the code, make sure that it actually works. Otherwise, if I don't do this, I could end up with changes that I don't know that I actually have a working test around. Remember, you really want to see the test fail so that you know it can fail before you make it pass. So let's see, my next test, let's check out defining a property. So let's see, let's optimize this a little bit. The target, I don't really need anything in there. That object can just be an empty object. Get rid of that. That simplifies my test a little bit. Does it still pass? Yeah, so let's write our next test. It should not be able to create a property in working memory. And so for that, I'm going to register a rule where we try to say, oh, wow. I effectively did this just a moment ago, and it passed. It passed, I think, because this is setting it. Okay. I think I'm understanding this a little bit deeper. The condition that I want to make happen here then is going to be, was it object.define property? And on our working memory with a property key of message. These brackets are really optional. Starting to bug me here. Cruft. Oh yeah, look at that. It tells me right off the bat. It's a trap for object.define property. Oh, if I'd just read the documentation. Oops. if I do that, now I ought to be able to assert that this throws. And this will fail because it won't throw. Yeah, so now I will plug in the next handler. The test should pass. Good. Now let's make sure we can't delete anything. And finish off our trifecta. Spell. We'll register. Is there a delete property? Yeah, delete. Is it just that? Yeah. And put a colon in there for us. Fail, and put our last one of these in play. Should pass. Yeah. So now we're checking all of the kinds of mutations that one might try to do on that property, and they are all failing. I'm going to call this a night. I'm kind of excited about this. I've managed to drop another half hour on this, and I'm really pleased with the results. Let's take a look at what I changed here. You know what? And this, okay, let me get this thought in place. Addition to keep the user from mutating the sounds like a plan. It's gone in now. Oops. Let me just amend that. Now, the next thing, I just want to leave myself a hint for the next time I'm actually in this. Put in just a pass-through getter. So pass-through getter would use reflect to get what does get pass in here? Target prop receiver. And what is that? Arguments. I'm going to pass that through in that way. And I'm going to use this trap to capture properties with which the condition is concerned. Let's check our tests. Ooh. Reflect get on non-object. I think we might have an old test where the data we pass in is not an object. Oh, we're not. That's interesting. We've definitely hit upon some edge case here, huh? Should process a simple rule. It's definitely on the filter. On condition, on the get. Am I using this correctly then? That's only a 2-parameter. Same error. All right, let's pick this apart a little. Oops. Oh my gosh, that mangled that pretty good for me. Let's stash this up here for a moment. Let's put some braces around it. See what that spits out the console on us. So we got the target, we got the property. Reflect, get. That was in the right order. Target followed by property. Target followed by property. I mean, target followed by property. Really? One day I'm gonna have to look into why that was. Interesting. All right, well that's fine. It's getting late for me, so I'm gonna call this pretty good. I think I'm gonna have to work that out though. That's just bugging me. I'm not quite sure how that spread operator works. Is that officially a spread operator? It's all the arguments of the function, I'm guessing. Let's just see what I can get out of this. Actually, you know what I'm going to do? I'm going to do something else. I'm going to put that brackets back around that. And when I do that, what exactly is inside arguments? Let's see what I get. What could go wrong? Well, that's not quite what I'm thinking of. I wonder if this is something that works differently as a lambda than it does as a function. Let's try an experiment. Let's make this a function. It takes target and prop that looks like this. Oh, something's broken. It's broken good. Huh. Where did this become recursive? Inside functions. Non-arrow functions. Yep. So this doesn't help me understand, though, why this became... Oh, of course. Huh. Yeah. I'm gonna pop that out. This should be good. Because it was reaching inside and console was trying to inspect the target and probably getting that property and triggering the functioning again. So thus we had infinite recursion. This is all happy. Oh, but that then means that I should be able to say this and get the behavior that I was looking for. Okay, so that explains to me why that didn't work. I don't like the verbosity of a non-arrow function here, so I'm gonna stuff this back to be an arrow function just to make it a little easier for me to read, which means that I can't use that arguments object. I'm gonna have to say target and prop directly, which I'm fine with for now. I'll just be explicit about it. And our test is still passing. All right, so I am ready to push this in. I've got myself a hint for the future. I'm going to use this to push forward. And then I think I'm pretty happy. I'll pick this up maybe tomorrow. This is exciting. Good to go. And I will see folks tomorrow.